So the topic is semiconductor physics. So we know that copper, aluminum, etc. are good conductors. So these materials have good capability of conduction. Similarly, some materials like glass, wood, paper, etc. These are called insulators or insulators. So in some applications, in some electrical and electronic applications, we will use insulators also. So conductors also. So there is another category of materials. Another category of materials whose ability to carry current called conductivity lies between that of insulators and conductors. Okay, so this is conductors, extreme, insulators. No. So the ability of conduction is lies between these two. So this is insulator, this is conductor. So the ability of conduction lies between insulator and the conductor. So we cannot say these materials as a good conductors as well as good insulators. Insulator means conductivity is very low. Conductors, they will have high conductivity. So the conductivity level of these materials lies between conductivity ability of insulators and conductors, which are called semiconductors. In the name itself, semiconductors. So we will know two popular semiconductors. One is germanium and silicon are two well-known semiconductors. So to understand how diodes will work, how transistors will work, how FETs will work, how an integrated circuit will work, we need a strong concept or a strong physical concept behind the behavior of semiconductor materials. So that is the use of studying this semiconductor physics. Now we will see matter. So matter means anything like solid, liquid, gas. So the matter which occupies the space may be solid, liquid or gas. So the matter may be anything. According to modern electron theory, matter is composed of atoms which in turn composed of three elements: proton, neutron and electron. Proton, neutron, electron. So indirectly matter is composed of proton, neutron, electron. So these are three fundamental particles. They are invisible to our eyes. Generally this proton has positive charge, electron has negative charge, and the neutron has uncharged, that is electrically neutral. And one more thing is the mass of proton is mass of proton and neutron is 1.67 into 10 power minus 27 kgs, and mass of electron is 9.1 into 10 power minus 31 kgs. That is, the mass of neutron and proton is same, while the electron is different. So if you compare the masses of this electron is very light particle, having very less mass. So it's a very light particle. Now matter is composed of proton, neutron, electron. This matter may be either solid, liquid, gas. Then why various elements behavior in different manner? Why aluminum acting as a different manner? Why copper acting as a different manner? Why silicon acting as in a different manner? Because all these materials are formed with proton, neutron and electron only. Then why these elements behavior in a different manner is because of the difference in the arrangement of electrons. Difference in the arrangement of electrons, protons and neutrons. So because of the arrangement of electrons, protons, neutrons is different in different materials or different elements. That's why different elements behave differently. Now we will say structure of an atom. So atom mainly consists of three particles: protons, neutrons and electrons. So all the protons and neutrons are bound together at the center of an atom. So, like this, center of an atom, which is called a nucleus. All the protons and neutrons are bound together at the center of atom. Center of an atom, which is called nucleus. The electrons, so protons and neutrons are bound together as a nucleus part, and the electrons are moving around the nucleus. Electrons will move around the nucleus. So this is, suppose the nucleus is a positive charge. So something like this. This is a nucleus. So the electrons will revolve around the nucleus like this. Like this, the electrons will revolve. So we can treat it as a nucleus, as a suppose nucleus as a sun. Around sun, planets will revolve. So around the nucleus, electrons will revolve. In general, in a normal atom, the number of protons is equal to number of electrons. Number of protons is equal to number of electrons. As neutron is electrical neutral. So an atom as a whole is electrically neutral because positive charge cancels negative part because neutron has no charge. So an atom as a whole is electrically neutral. That is, an atom has no charge at all. We know that the number of protons in an atom is called its atomic number. It's called its atomic number. And the atomic weight is approximately equal to the total number of protons and neutrons in the nucleus of an atom. Here we saw that the electrons are revolving around the nucleus. So these electrons are arranged in different shells. The electrons are arranged in different shells at a fixed distance from the nucleus. So each shell can contain a fixed number of electrons. Each shell can contain a fixed number of electrons. In general, a shell can contain a maximum of 2n square electrons, where n is the number of shell. Where n is the number of shell. So the first shell can occupy a maximum of 2 electrons, while the second shell can occupy a maximum of 8 electrons. Suppose if you consider silicon, if you consider silicon atom, if you consider a silicon atom, the atomic number is 14. The atomic number is 14. That is, the number of a silicon atom consists of 14 protons and 14 electrons. So in first shell, so number of electrons is equal to protons is equal to 14 for a silicon atom. So the first shell contains 2. So the first shell contains 2 electrons. The second shell can contain 8. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 2, 10 is over. Remaining is 4. So the last shell. So the last shell. This is last shell for a silicon. So the last shell contains remaining 4. 1, 2, 3, 4. So this is the basic construction of a silicon atom. So the last shell electrons are called valence electrons. The last shell electrons are called valence electrons. Here one exception is each shell can contain 2n square electrons except last shell. That is, the exception is the outermost shell. Outermost shell, that is the last one, can contain maximum of 8 electrons only. This is the exception. The outermost shell can contain maximum of 8 electrons. So this is the exception to the 2n square rule. So this is the basic construction of a silicon atom. Similarly, germanium also has 4 valence electrons. So valence electrons means outermost shell electrons. Here for silicon we have 4 valence electrons. So the structure what we see is like this. For silicon we are having 2 here, 2 electrons, 1, 2, 8 electrons in the second shell and 4 electrons in the outermost shell. So this is the last shell, which is called valence shell. And another important thing is each shell has an energy level associated with. Each shell has an energy level associated with it. Suppose the first one has an energy level E1, the second one has an energy level E2, the third one has an energy level E3. That is, if the electron is close in the first shell, the electron is close to the nucleus. So the electron is close to the nucleus, there is always a tremendous force of attraction. Suppose if you consider the last shell, the force of attraction between this and the nucleus is very less. So we can easily extract the valence electrons compared to first shell and second shell electrons. So in general, these valence electrons, so valence electrons means electrons present in the last shell. So valence electrons are responsible for electrical characteristics of an atom, because these are loosely bonded with the nucleus. So one more thing here we discussed, each shell has an energy level. In general, E3 is greater than E2 is greater than E1. So the valence shell has highest energy level. So highest energy level. Here what is the exact meaning of this highest energy level is the amount of energy required to extract the valence electron from the outermost shell is very less. So here highest energy level means the amount of energy required to extract these valence electrons from the atom is very less. That is obvious, because the valence electrons are, the force of attraction between the nucleus and the valence electrons is very less. So we need only less amount of energy to extract the valence electrons comparing with first and the second level. So that is the exact meaning of highest energy level here. Suppose in some cases, generally as a whole, atom is electrically neutral. We know that. Suppose if an electron is extracted from the outermost shell, then what happens? So number of protons are greater than number of electrons if an electron is extracted. So because electron is a negative charge, so the overall negative charge of the atom decreases. But as the number of protons remains the same, the positive charge remains the same. So atom as a whole loses its electrical neutral nature and said to be positively charged. That is, if atom lose a electron, implies it becomes positively charged. Suppose if an atom lose a proton, as a whole it becomes, or if atom gains an electron, if an atom gains an electron, so gains an electron means the number of electrons increasing, so as a whole electron charge is becoming more, so then it is said to be negatively charged. So the atom become positively charged and negatively charged. So this is a basic concept of an atom and how the three fundamental particles align within the atom. So it depends upon atomic number of the element. So this is, here I discuss only a single atom because silicon contains many number of atoms. So I consider a particular element, suppose many number of atoms like this. I consider only a particular atom and I discuss the concept. So this is the basic concept of atom and how the particles align within the atom. So this theory is very important to understand the energy band theory of a semiconductor material.